slides or just keyboard, right? Yep. Yes, sir. So, hello everyone, I'm Satish. I'm a Ruby and JavaScript developer. This talk is about how I built 10 apps in 10 days using JavaScript on top of an API platform that I built called APIfy. At a very high level, this talk is about responsive design and mobile backends. So, this is Thomas Suarez. He is the world's youngest iPhone app developer and he is just 12 years old. Here he is giving a TED talk on how he started building mobile apps and how he convinced his parents to pay $99 so that he could publish his apps on the App Store. Tablets and smartphones have become a very integral part of our lives now. This is a 1-year-old baby. She is so used to the iPad that she starts to think a magazine is like a broken iPad. And this is what Robert Kirsch, the guy who invented the world's first programmable computer, has to say about things like iPad. So when people use products like smartphone and iPad, separate the act of consuming things from the act of building things. So when people use an iPad, they end up using technology to consume things, but when people use a computer, they can start making things, and once they start making things, they can do things that have never been done before. So that's one of the reasons why we have very few people who are young and are into programming and making apps. iPhone or iPad is kind of like PCs in the 90s or Commodore 64 in the 80s. In reality, we should be having a lot more people who are making apps, but we have very few examples even in US and in India. One of the reasons for this is the way we distribute apps. So this is how people were used to distributing apps before the iPhone. So you take your source code or your executable and you share it with your friends using CD or floppy or email or IM. Or better, you use a programming language like PHP or Python or Java, and then you make a web app and share the URL with your friends. But this is how people distribute their apps for platforms like iPhone, Android and iPads. So you program in a language like Objective-C or Java, which is quite complex for a beginner. And you use a development environment like Xcode or Eclipse, and you spend a lot of money to get a developer account in Apple or Android, and then you publish your apps and then you share it with your friends. This is not how people who programmed before the iPhone are used to sharing their apps. So can we have an easier way for beginners to build and deploy apps? This is not something new. So you can use a combination of HTML5, JavaScript and a responsive framework like Twitter Bootstrap so that your app works on any device. And you can deploy your apps in EC2 or Heroku so that it's easier to share instead of going through an app market. And if you're just starting and if you don't want to maintain your own database servers or backend servers, you can go for mobile backends like Parse or Firebase or APIfy, which provides off-the-shelf platforms for you to build data-driven apps. So before we get into the demo of the 10 apps, I just want to make it clear what kind of apps we're not talking about today. So we're not talking about native iOS or Android apps. We're not talking about building games like Angry Birds or how to build the next Instagram. We're talking about very simple apps like this. So let's say you want to build a hangman game, and the data for that hangman game comes from popular movies. The thing here is Wikipedia or IMDb has all the data that you need for building this app, or just the data backend for this app. All you need to do is build the front end and wire it to that backend, and you can get your app working. So the first thing that comes to your mind if you want to build an app like this is, how do you build the front end? You have several choices here. You can build your front end in native iOS or native Android, or to keep it very simple, you can even build it in just HTML and JavaScript. The second question that comes to your mind is, what kind of backend do I need for this app? So the choices you have are, you can dump all the movies that you have. Let's say you have 250 or 1000 movies. you can dump all of that in a SQLite database and use it from your app. The question here is, how do you update the movies? Or you can just use a new platform or language like Rails or Django and build a RESTful web service, and which is used by your app, and you can keep on updating the app from the backend, so the app is separated from the backend data. Or you can use some data backend like Parse or Firebase or Deploy to get an off-the-shelf backend and use it from your app. So APIfy is kind of like one of these backends like Parse, Firebase or Deploy. So what exactly it does is it converts structured data in any website and then converts it into JSON. So the possibilities of this is, you can take up any website. So the possibilities of this is, you can take up any website, convert that website into data and then use it from your apps. So just to give you a very high level example, what is shown on the left side is the Hacker News front page. So if you're building an app on top of this, you'll want to convert this page into an API. So to convert this into an API, all you need is the URL and certain attributes like title and the link, rank or stuff like that. So APIfy takes this and converts this into a JSON API. I need some demo. Okay. So coming back to our Hangman example, if you want to make an app using data from IMDb, you'll just take IMDb's top 250 movie list and then convert it into an API, which can be directly used from your apps. So this is actually an open source library, and it is made of two parts. One of it is called Scrapify, which is kind of like a generic site scraper. So what it does is, you declare a model for a web page from which you want to extract data from, and then you can use an active record like interface to extract the data. So if you have a model for IMDb, you can basically say movie.all to get all the top 250 movies on that page, or if you want to filter by director, you can say movie.find by director and do the filtering. The second part of this is called JSONify. So what this does is, it takes a model in the previous step and then provides a pluggable layer which can be used to convert it into JSON. So even this is open source, and you can just plug it into any Rack or Sinatra or Rails application to get JSON data from any web page. So APIfy is just a web front end for both of these libraries, and the moment you start having APIs for any data on the web, you can start building apps on top of it. Those are the kind of apps even the publisher or the content creator of the website would not even have imagined. So with all this, you must be thinking that there are only a very small subset of apps that you can build this way. That's what even I thought, but it turns out you can build a lot of apps this way. The rest of this presentation will be a walkthrough of the kind of apps that I was able to build using this approach. So the first app that we'll be looking at is a Subway sandwich generator. So there are two kinds of people who go to a Subway. Those who know exactly what they want to eat, and those who happen to live near a Subway and just want a random sub. This app is built for the second kind of people. So just to give you a quick demo, this is the app. So it has 5 different APIs, one for meat, one for bread, one for cheese, one for a set of ingredients, and one for sauces. So all of this is derived from Subway's main website, and it basically uses those APIs to randomize and generate a random sub every time. So the way this works is, it has got, can you see the code from here? So the way this works is, there are 5 different APIs, one for bread, cheese, like I said earlier, and it uses jQuery's $.when to chain all of these AJAX requests and once it has loaded all the data is just the name of the ingredient plus some image which is representing that ingredient. It uses $.when to chain all of these AJAX requests, and it generates a random sub based on whatever data is collected so far. So the next app that we are going to see is a game. So this game is based on a TV show called Breaking Bad. So that show has character names with the periodic table elements embedded in the character names. So the way the game works is it's actually built from two different APIs. One is the list of character names in the TV show, which is from IMDb, and the second is the list of periodic table elements from Wikipedia. So it uses both and then embeds an element in a character's name. So all you have to do is guess the element and you score points for it. This was actually a pretty popular game in Facebook and Reddit. The way this works is again pretty similar. It has got two different API URLs. It uses $.when to chain these requests and then uses that data to randomize and show different character names, and it also keeps a score here. The next app that I was able to build was a random Tirukural generator. So the way this works is it uses a Project Gutenberg-like site to get all the 1330 Tirukurals, and it's able to index a Tirukural by a given ID. So this is the API URL for a single Tirukural. So if you see there is a placeholder for an ID there. So I can look up any Tirukural by using an ID, and it will return that code as a JSON. So this app basically generates a random number and uses that to display a Tirukural. So the next app is an IMDb movie tracker. This is an offline offline storage movie tracker for the top 250 IMDb movies. It lets you know what movies you have seen or not seen in the top 250 movie list. So this is built using stash.js, which is a JavaScript library for offline storage. So the way this works is every time I check or uncheck a movie, it kind of updates a key value pair in stash.js. So even if I revisit the app, it will get the movie list from stash.js, and it will actually remember that I've seen a specific movie. So the next game, the next app is a chess puzzles game. So it's called Mate in One, and it's an imitation of a pretty popular game on the iPad. This is built using jQuery chess plugin and a puzzle archive site which contains over 1,000 puzzles. So the way this works is it has a collection of 1,000 puzzles, and each puzzle is represented using just two strings. One is an FEN notation which represents the board position, and the second one is a solution to the puzzle. This app particularly does not involve any game AI because you can actually solve each puzzle using just one move. So the way it's implemented is it initializes a chessboard using jQuery chess plugin, and for every puzzle it initializes a board using the puzzle's FEN notation, and it provides a callback method which intercepts every move on the chessboard. So all it has to do is compare the first move to the solution of the puzzle. If it matches, the player won, otherwise the player lost. So just to give you a quick demo, this is one of the puzzles. It has well over 1,000 puzzles here, and this is the jQuery chess plugin, and every time you move, it compares that specific puzzle's solution to whatever move you did, and you get points based on that. The next app that I was able to make was Rubik's Cube patterns application. So you can use this app to form pretty patterns on the Rubik's Cube. So the way this works is it has a collection of 40 or 50 patterns, and for each pattern it has a sequence of moves, and the moves are represented using standard Rubik's Cube notation. So this is built using HTML5 Rubik, which is a plugin, and this is built completely using just CSS and JavaScript. You can execute the moves step by step to know how to form a specific pattern, or you can even rotate the cube to see how it looks. So this even works on a touch interface, and it's only CSS and JavaScript. So the next app which I was able to build was a data visualizer. So what you're seeing here is this is built using gmaps.js. It can take any data which has location as one of its fields, and it can use that data to plot it on Google Maps. So this is built using gmaps.js, which is a wrapper over Google Maps. The second part of this is a visualizer. So what you're seeing here is a visualization of Forbes billionaires on a bubble chart. So I can just show you a quick demo of this. This is built using d3.js, and it uses APIfy as a data source, so which is indirectly derived from another Forbes listing of billionaires. So here the size of the bubble represents the wealth of the person, and the color represents his country. The distance along the x-axis represents how wealthy he is, and the distance along the y-axis represents how young somebody is. So this is again a very simple game. So as you all know, rock paper scissors is a pretty simple game in that there are only 6 different combinations in the game and 9 different permutations in the game. So this is rock paper scissors lizard spock, which is from Big Bang Theory. So this has got 10 different combinations and 25 different permutations. This table which you see here is the normal form representation of the game rules. So a 1 here represents a win, a 0 represents a tie, and -1 represents a loss. So what I've tried here is taken this data, which is like 25 different permutations, and use that to see if game rules can be represented as just data instead of logic. So the implementation of this game is very, very simple. So what you're seeing here is an image map. So every time you select something on the image map, it'll find a matching rule amongst the 25 rules, and in that rule it basically checks if it's a 1 or a 0 to determine whether you won or lost. So the next app is a public transit application. It's kind of like bus routes. This is probably the only useful app in the entire list, and so the way this works is, for any given city, if you want to travel from X to Y, it lists all the public transport routes that you have to take and any transfers that you have to make. And this is built on top of Wikipedia. So what you're seeing here on the left side is a wiki page. Wikipedia has a list of bus or train routes for most of the cities. So this just takes that data, converts it into API, and what it's doing here on the browser is building a graph from that data, and it's executing Dijkstra's shortest path algorithm on the browser. It's actually pretty fast because it's just constrained to one city, and there is not more than 1000 routes for any given city. So to show you a quick demo, this is an implementation for Wikipedia Chennai bus routes page. So if I want to travel from any location X to Y, it will execute the shortest path algorithm on the browser using like not more than 1000 routes, and it will display the route from X to Y. The next tab that you're seeing here is a programmer's search engine. So this is built on top of a site called Hyperpolyglot. Hyperpolyglot classifies languages as into families as static, dynamic, or ML or Lisp-like languages. So what this does is it takes all of the data from Hyperpolyglot and then indexes the languages so that you can find out how to do any operation across a set of languages. So let's say you want to know, how to do parallel assignment in Ruby, but you want to know how to do parallel assignment in Perl. So you can basically search here, and it will list all the languages in which it knows how to do parallel assignment. So let's say you want to learn how to do it in Perl using your knowledge of Ruby. So you can select or deselect languages, and it will display example code. So this is how the original site looks like. It has a family of languages, and for each family it has a table listing all the operations that you can do. What I've done here is I've got all this information and combined those APIs to make the search work. So all of these apps are just HTML and JavaScript. You can actually use any stack for this. I've used Sinatra here so that it's easier for me to deploy, and possibly use Haml, SAS and CoffeeScript. So all of the code that is used in these 10 apps is available in this specific GitHub URL. And apart from these 10 apps, the platform which I'd created, APIfy, was used extensively during Olympics. It served almost 1 million requests during Olympics, and it was used by more than 5 or 10 apps. So APIfy is actually pretty limited in that you can only do GET requests using it, but there are other platforms like Firebase and Parse which let you do any kind of request like GET, POST, PUT or delete. What makes all of this possible is a combination of JSON-P and CORS. So CORS stands for Cross Origin Resource Sharing, and it lets you make RESTful GET, POST, PUT, delete across domains. And CORS support is actually pretty extensive in almost all modern browsers except few. I'm kind of done. So you can actually check out all the apps that are built with APIfy here, and even the open source library is available in this GitHub page.
Questions?
Yeah.
Hi. So one question. So you're scraping off all the data from HTML pages, right? So my question is, how do you handle malformed HTML? As in, browser is graceful enough to handle even HTML which is not completely formed. But here API has to be very specific. So how do you handle that?
So that problem occurs when you're actually building the API. So I think it doesn't work for malformed HTML. It works only for proper HTML.
So how much time did you took to build this 10 apps?
So I started building these apps after building APIfy. So all of these apps took almost like 1 or 2 hours in a day.
And
each of these apps.
How much time it took to build APIfy?
So that was built over a weekend.
Wow.
More questions for the speaker? Yeah.
So with APIfy, if I want to say download a list of top 250 movies, so do I need to specify the URLs, or I can just point it to one URL and it can get the data?
Do you mean like download the movie data?
The movie list. So say 250 movies, I want to download the data about the actors and actors.
Yeah.
So do I need to specify 250 URLs, or I can give it one URL and can scrape it and then go to a corresponding?
If all the URLs form.
Yeah. So there's like IMDb has one top 250 list, right?
Yeah.
So and then there are links to individual movie pages.
You can actually have one API for the listing, and if each movie has the standard URL and standard selectors for each page, you can have one API for all these 250 different movies, and it can give you details of those 250 movies. Okay. It supports dynamic URLs.
Okay.
Yeah. Can I? Yeah. So have you seen Yahoo Media Query Language? Is it like similar to APIfy?
Yeah, it's kind of similar. It's kind of similar, but this gives you JSON directly.
Where does this passing of the HTML happen? The server?
Yeah, it happens on the server side. So I can just show you an example. So this is a corresponding API for the IMDb site which I showed. So this is a testing page for the JSON API. you can even test by one movie, I guess. So this is derived from this IMDb page, and the way it is built is by specifying different attributes and saying how to get all those attributes from using either a CSS or XPath selector. So this part is pretty generic for any web page, and you can do this for any page.
So you just have to hit the apify.heroku.com to get
Yeah, this URL will give you the JSON.
Okay.
Excuse me. So, APIfy, is it a library or is it a service?
APIfy is a service, but underneath it is there are two libraries called Scrapify and JSONify.
Oh, okay.
It's just a front end for those two libraries.
Okay.
Last question.
Yeah, does it have support for local storage or InnoDB?
That is actually by I think for that it uses a different library called stash.js. That's an interface over any browser's local storage.
As such, what I understand right now, you're having a specific third-party backend API, say parse, to use your. But if I want to put all the data, say in my local storage, and use it as a complete offline app, I need to use another library.
Yeah.
Okay.
That has nothing to do with API.
Thank you.
Hi. I just one more question.
Yep.
So what I was wondering is that in case of really well-formed URLs and pages, this seems a great solution. But what if you've got to form URLs with certain parameters or post certain parameters to get certain data out of pages? Just a slightly more complicated scraping use case.
It works only for GET requests. So if you have something like something where the URL has a dynamic parameter, you can still use this, and you can pass those parameters in the API call. It will substitute those parameters in the URL and make a call again.
And what if the website tends to have, like, you need to make a first call where it probably gives you a bunch of like a session ID or something, and only after that the second request with a set of parameters can get you back the data?
It doesn't work with authentication. It works
Okay.
on direct requests.
Okay, but this seems great. Thanks a lot.
Yeah.